Hello, my dear lovely students. How are you? I hope you are quite well, happy, and healthy. Your study is very smoothly going on. Uh, Today, we are going to discuss the cross Cannizzaro reactions. See, students, once you understand, please like, share, and subscribe the channel. See, here is a cross Cannizzaro reactions. Okay. See that the cross Cannizzaro reactions. Cannizzaro means what? Those compounds which do not have alpha hydrogens, no alpha hydrogens. Okay, like that formaldehyde, like that benzaldehyde compound we will take. So these compounds undergoes into the Cannizzaro reaction. Now cross means two different compounds. So when two different compound will take two different compound, those which do not have alpha hydrogens, right? Like this two compound when we will take, that will involve in the Cannizzaro reactions. Let's understand through the example. Student, here is the HC double bond OH and benzaldehyde we have. As you know, the formaldehyde is more reactive as compared to benzaldehyde. Benzaldehyde resonance is there. So when we'll take the conc NaOH, what will happen? That part will be oxidized. So HC double bond O, ONA, and second part will be the reduced form, that is the CH2OH. Here is the name is sodium benzoate, and here is that benzyl alcohol, right? See here, students, one more example. So what we have seen that here, this is oxidized form and here is the reduced form, right? One more example is here is that benzaldehyde, and second is that compound will take that CHO, NO2, P-nitro benzaldehyde. When we'll take the concaneH, what will happen? This is the more reactive because NO2 group is there. So this part is more reactive part, that is going to be the oxidized form. And what will happen? COONA, and here is that NO2, and that form is going to be the reduced form, means CH2OH, right? See here, that is a reduced form, and here is the oxidized form. Just in one more example we will take here, that is the 2 moles of glyoxylic acid. So glyoxylic acid, CHO, COOH, right? And here is that CHO and COOH will take along with the 3 moles of sodium hydroxide, and we supply the sodium hydroxide. So what is going to be happen here? Students, see, one part of compound will be oxidized, other part will be reduced because both have same compound. So their reactivity is also same. So one part is oxidized. Suppose this part is going to be oxidized. Since here is the acid, so sodium is NaOH is a strong base that will react with the acidic hydrogens. So here is the what? This part is going to oxidize. So COONA and COONA will form. Along with that, CH2OH, because this is the reduced form, and here is COONA will form. Correct? So what is the name of this compound, students? That is name is sodium oxalate, and here is the sodium glycolate will form, right? See this all these example we have seen, that is the undergo into the cross Cannizzaro reaction system, right? See, what do you think about this compound? I write here chloral, CCl, right, and COOH. Can you tell me, would this come here? There is a compound will involve in the Cannizzaro reaction or not? I'm writing here about the chloral compound. So chloral will involve with the Cannizzaro reaction or not? See, students, when we take the conc NaOH, what happens? See, instead of Cannizzaro reaction, it will form chloroform CaCl3 plus HCOO negative. Okay, so means neither this compound formaldehyde contains alpha hydrogens nor chloral contains alpha hydrogen. Despite being will not involve in the Cannizzaro reactions in the cross Cannizzaro reaction. Why? See, we understand whole the concept through the mechanism. C double bond OH, right? So we have the OH minus which will attack here, and that the C O negative HOH will form, right? So what happens, twins, when we'll take the second moles of formaldehyde, when we'll take here C, Cl, 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 C, O negative and OHH. When we'll take the second mole formaldehyde, usually what happens in the Cannizzaro reactions, the hydride shifting is there, hydride shift is there. But instead of hydride shift here, instead of hydride shift, that will move here, and it will form that Cl negative. So now my question to you, what do you think? Which is the better living group? This compounds or here is the hydride. Obviously, this compound is going to be the more stable. Students, any living more stable means when they leave the positions after that, how much they are stable, that decide the stability of the uh, any living groups. So here is the part. This part is going to be the most. This is the most stable living group. So instead of hydride transfer, that will move away from the reaction site. So that is the region, and that is the region that the compound is not going to undergoes into the Cannizzaro reaction. So now see what will happen when that will move here. It will come back and Cl3 negative plus HC double bond OH, and here is the acid base reactions. Acid base reactions. So H will transfer here. That will form the CHCl3 plus HCOO negative. So what did you understand? One thing here is this aldehyde. Here is this second aldehyde. There is no work of, there is no use of these aldehydes, right? So that is the reason such of compounds will not involve in the cross Cannizzaro reaction strengths. Okay, here is that such a compound will not involve in the cross Cannizzaro reactions. Now I give the one example. You tell me the answer of this compound. Here is that CHO, okay, and here is the OCS3. Second compound is here is CDO and OCS3. Can you tell me when we will take the concatenate, what will happen? What the product will form? Students, CHO and CDO, which is more reactive. Obviously, CHO is more reactive than the CDO. So, D means deuterium. So that part is more reactive. Will be oxidized. So what will happen? There is the COONA, and here is the OCS3, and second is that CDHOH will form. Correct? So I hope students understood that all the cross Cannizzaro reaction parts. Thank you. Have a nice day.